Okay, so now that we have written out our steps over here, and we have written out like the individual robot steps over here, then translated that into an outline for what our code needs to do, then what we can do is basically take each one of these problems and start translating them into Python, right? So let's take our smallest problem. Is the input number prime? So let's copy that, and I'm just going to put it over here so I have kind of a blank slate to deal with. Now, part of the reason why I gave this a label is so that I would have a function that I could, so that I could label this as a function, right? So def, so what it says here is the input number prime? That's what this problem is really trying to solve. So I can say is prime, right? And that's sort of the name of the function. So I can just say def is prime. Now I know I'm going to be given an input number, n, and so now I've already got my function scaffold, right? So that's what I'm doing here. I'm given an input number, I'm determining if it is prime. So now I have a nice comment that tells me, what is this doing, and I have an outline for what I need to do. So I'm going to tab this over. And as you can see, since I'm using syntax highlighting for Python, this for is already highlighted as the beginning of a loop. So we're going to be writing a for loop. Now, for every number under the input number except 1. So now what we have to do is translate this into a for loop. So the input number, what is the input number? Well, it's actually a variable called n, so we're just going to replace n. For every number under n except 1. So how do we get an expression that represents every number under a certain number? Well, in Python that's called range, right? And we want to go, we don't want to start with 1, we want to start with 2, right? So for every number under range of 2 to n, right? And so what we now have every number under range of 2 to n, but we need a variable here to represent each number that we're going to check. So for current number in range. So now we've translated that statement, right? Okay, so what's the next thing we're doing? Check to see if the input number can be divided evenly by the other number. Okay, so you may notice this word is highlighted. So we can start here. If the input number, if n, can be divided evenly. So how do we know if something can be divided evenly? There is a operator in Python called the Modulo Operator. And what it allows us to do is check to see if a number can be divided evenly into another number. So if n modulo can be divided evenly, modulo, by the other number, current number, is 0, as in there isn't any remainder. The modulo calculates the remainder. So if the remainder is 0, then we're dividing evenly. So if n divided by the current number is 0, then that means it divided evenly. So if we go back here and we look at our steps, if it can't be divided evenly, then we should keep checking to see if there are any other numbers. But if it can, the number is not prime. So that means that we need to return false. Okay? And we don't really have to tell Python to move on to the next number. So we can just kind of get rid of that line there and make sure it's properly indented. Now, this is how we can find out whether a number is not prime. But we don't have anything that will handle the base case for if it is prime, right? So if the current number never ends up being divisible, so if we get all no's here, no, 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 over and over again, then we know that what we should do is return true, right? And so that's what matches, this function now matches this process, right? Go on to the next number, which is 5. That's 5 being dropped in here. And then what we do is we say, is 5 divisible by 2? And then, so that's is 5, n is 5, divisible evenly by 2, right? Current number is 2. And then if that's false, then we just move on. We don't, this is not true, so we don't return false. We just go back up here, and then it's is 5 divisible by 3. And so we iterate through, and if we get all no's, then we'll return true. So that was implementing, right, which is the I phase of the umpire acronym, and then reviewing it, right, UMPIRE. So we're reviewing to just make sure that this is probably what we think it is. Now the next thing that we want to do is we want to solve the rest of the problem. So I'm just going to move this on over, right? I'm going to keep all my other information just so that I can return to it in case I kind of get lost or confused, right? Given an input number. And then this is count primes. So this is the actual problem I'm trying to solve. Def count primes, right? We're given an input number, n. And then we already have our for loop for every number under the input number. So for, and then how do we do every number under the input number? Well, we did for current number in range. So I'm just going to copy that and paste it here because it's the same thing going on. Check to see if the number is prime. So in order to check to see if the number is prime, we've already solved that problem. So we can say if current number is prime, right, then we can add it to the number of primes that we've found. And then if it isn't, then we don't add it to the number of primes that we found. Now, right now we don't have any way to keep track of how many primes do we have, right? And I kind of didn't write that in my plan, but we know that we need to keep that information because that's the output value. So I'll just say count of primes is 0 to start off at 0, and then what I can do is count of primes plus equals 1. So that's marking it as prime. And then if it isn't, we're not really doing anything. We're not counting not primes, right? And so now what we can do is return the count of the prime numbers, count of primes. So now I have a solution that I think will work. That review phase is a really key important phase.